In this video, a customer reports a problem with a flat pattern not showing correctly. And I'll go through and analyze the geometry and suggest perhaps a better technique for doing this. So here is the original part file. And I'm going to go and look at the first sketch. And I see from the first sketch that it was started out as a flat part and then folded up. I'm going to suggest that any time a beginner is tempted to use the fold command, that the dialog box should actually come up and say, are you sure you want to do this? Have you checked with an expert to make sure that this is the best way to do it? Fold should be very, very rarely used. There are some cases where you would use fold, but I would say it should be a very rare occurrence to do that, to use a fold. And so this was folded 90 degrees, and then this was folded with some arc radius, which we'll look at in a minute. And then I created a sketch on the end of this part, and we'll look at that sketch. And so let's increase the number of decimal places out. So I'm going to go to the Manage tab, or Tools. I'll go to Document Settings, and I'm going to go to Units, and I'm going to increase the number of units way out. And we might do that on angles too. If I look at these numbers, if I'm working in inspection and I have to start inspecting this part, none of these numbers make logical sense to me. Now sometimes what I'll do is I'll check in both inch units and in metric units to see if maybe it's just a matter of conversion from metric to or from inch to metric. But you know, so for the height of this, for this vertical piece right here, is the height, you know, so is the design specification, would the inspector inspect it from here to here, or from here up to the implied intersection of this line and this line, or this arc and this line, you know, up to here? So where is it inspected to? Now what is the critical dimension? And you know, I don't think you can manufacture something out to 8 decimal places, so I would expect it to be something like 16.34 or 16.35 instead of going all the way out here like this. And then I would expect that this point right here was dimensioned from here or over here, or this point up here, or the midpoint here, something over here to tell me where this curve should end. And I wouldn't expect it to be, you know, a really oddball, strange number like that. Now the original part was something like 143 millimeters wide. I took let's just double click on this. So I added up the arc length of this dimension. Actually, I think this one is up here. The arc length of this dimension, arc length of that dimension, and then this height from here to here, and I get 148. So that's the length of the curve along there. And then I did the same thing on the inside of the curve. So the 143 would be somewhere, you know, in between here and here along there. But how do you inspect that? And what purpose does it serve? You know, you want this thing to fit in an assembly. So let's look at how I might model this part. And so I'm going to start a new sketch. Let's see which plane that was on. If I rotate around, I'm going to go to the bottom view, and I'll put that, let me check, I'm checking to see where the origin planes are. So I'll go to the bottom view and I'll start on the XZ plane. Alright, so let's go to bottom view, upside down, I think that was. And actually, I'm going to turn it, it'll be easier for me to work if I do it upside down like that. The way I looked at it originally, and I'm going to go around like that. Alright, so I will do the XZ plane. And I'm going to draw a line going straight up. And then I like to dimension that line immediately for a sense of scale. Now I'm not sure, which one of these dimensions to use, so I'm going to use this one, and I'm going to round that up to 21.3. It can be edited later as needed. So I'll dimension this as 21.3. And then I'm going to do a 3-point arc, and I'm going to do that arc from here over to here, something like that. And I'll dimension that arc. I'm going to round that. I'll do that as 380, and then I'm going to do this 118 from here over. So 380 and 118. So I'll dimension this as 380. And the distance from here over to here as 118. Now I need to dimension one more location, either the center of this arc or the vertical height of this point. I think I'll do the vertical height of that point. And so let's go back here, and I'll dimension the distance from here to here. And I'm going to call that 4 millimeters. And so dimension from here to here, that vertical height is 4 millimeters. Now notice when I put in that dimension, everything is fully constrained. All right, I've already set up my sheet metal rules, so I have 5 millimeters set in as my thickness, and that will be the inside bend radius across here. And so let's go ahead, and I'm going to create a contour flange. Notice it's going to put the bend in there for me, the 5 millimeter inside radius, and the distance I want to go on this then is 800. Okay, so there's my piece of stock that I'm starting from. Now I've got two different ways of putting the cuts on here. I'm going to give you an idea of the first way, and then I'm going to do it a second way. I could do unfold. I'll select this face, tell it to add all bends, and I'll say OK to that, and do my cuts on here, and then click refold to fold that back up. Now unfold refold is different than doing fold or doing create flat pattern. And again, I said I would suggest that you almost never ever use fold command. You'll end up with some results that are really can't be inspected. They're probably not what you intended. I'm just going to undo that, and I'm going to show you a separate way. Now this works because I have a flat face here. If I didn't have the flat face, I might have to do it differently. But I'm going to click on that face, and I'm going to tell it to do a new sketch, and then I'm going to tell it to project flat pattern onto that sketch. So I'll do project flat pattern, and I'll select the furthest most face out here. I'll select this face. It projects that as though it was flattened out, and then I can do my sketch of the geometry that I want to cut away on this. So I didn't have to flatten the part out. I could just flatten the sketch out to do this. Now I prefer to change all this geometry to construction. You may or may not, well, you probably don't need to do that, but I just prefer to do that. And then I'm going to do a slot, and I'm going to do that slot over here. Now be careful if there's any midpoints here. You don't want to snap to a midpoint. And I'm going to put that slot over here about like that. Now I'm going to put the dimensions on here. So from here to here is supposed to be 10. And then from this edge to this edge on the original sketch, it was given as 19.5. Now I might dimension this to the center of the slot, but that's the way it was given on the original, so that's the way I'll dimension it. And then this distance was given, and actually it was given actually the dimension to over here, not to here. I would probably dimension it to well, we'll just do it the way I need to put a point here to dimension it the way it was on the original one. Okay, so I'll dimension from this point over to here, and that distance is 75. Okay, so I've got that portion done. And then I'm going to cut some of it out over here, so I'm going to draw a line from about right here. I'll come down over to here, and I'll come over to here, and I'll come back over top of this. And now it didn't really need to change this line and this line to construction, but I just prefer to do that in case I make a change that would cause those two lines to go sick. My entire sketch doesn't go sick. I'm going to dimension this distance as 500. I will dimension the distance from here to here as 100, and I'll dimension the distance from here down to here as 43. Okay, so now my sketch is fully defined. Now I would really kind of question about this 43 dimension. Normally I prefer to take all my dimensions from the same datum, and you know, let's you know, so I would normally, I think I'd probably, you know, dimension from this line right here as the datum. And notice if I do that, you know, what is the critical dimension? Because see, this is going to get folded over, and you know, is the critical dimension, is it from here, which you know, notice there's some bend allowance in here, or is it from over here? Got to be really careful about selecting your datums, but this is the information I'm given in the original, so this is what I've got to work with. Also, so if I dimension this, the overall width, you know, bend allowance is taken into a consideration, so it isn't exactly 143. You know, you gotta consider your bend allowance, or let Inventor take care of your bend allowance. All right, I'll finish that sketch, and then I'll do cut, and I want to cut out this area, and I want to cut out this area, but I don't want to just cut you know, going this way. There isn't anything there, so I'm going to tell it to cut across the bend, and it wraps that around the bend, and I'll cut that away, and there is there's my finished part. And if I then go to create flat pattern, there is my flat pattern that includes the calculation of bend allowance. So again, I would very, very rarely use this fold command.